A student finds that the mass of 25 milliliters of an unknown liquid is 20.5 grams. What is the density of this substance? All right, so remember with this one, we have to break it down into steps. So we start very simple. D equals, because we have density here. Do we know what our density is yet? Great job, we don't. It's a question mark. Now, 20.5 grams, what is that? Great job, since we have grams, it is mass. So we have M equals 20.5 grams. And then finally we have milliliters right here. Whenever we have milliliters, what are we talking about? Great job, we're talking about volume. So V equals 25 milliliters. So what should be our next step? Great job, we figure out what formula we need. So which formula do we need here? Okay, great job. It's density, or D equals M over V, mass divided by volume. Remember, when you're unsure about which formula to use, go back to your formula chart in your reference materials, find the formula that has all three of these letters that you wrote down, DMV, and match the correct formula. So what's our next step? Great job. We start with our basic triangle here. Don't forget multiplication at the bottom, division on the side, I for inside the house, O for outside the house. So D, M, V. Then we can rewrite our triangle, this time inputting the numbers that we're using. Still have to bring all this over. So let's start with D. Do we know what D was? Great job, we don't, so we put our question mark there. Do we know what M was? Great, we have it up there, 20.5 grams. And finally, do you know what V is? Great, we also wrote it down, 25 milliliters. So now we can divide. Don't forget which one goes inside the house and which one goes outside the house. So let's start our division. 20.5 divided by 25 milliliters. All right, so remember, when you have a decimal inside the house, you don't have to move it. It's only when it's outside the house that you have to move a decimal. So in this case, we're good to go the way we are, and we can immediately start to do our division here. So 25. Can 25 go into 2? No. So we have 0. Can 25 go into 20 now? Because now we're looking at 20. Can you go in there? No, it can't. So we put another 0. Bring up our decimal. So now we're looking at the number 205. Can 25 go into 205? Great job, it can. So we have to figure out exactly how many times it can go in. So how many times is that? Great job, it goes in a total of 8 times. So in that case, we have to multiply 25 times 8. What does that give us? Great job, 200. So we subtract 5 minus 0. Great job, 5. 0 minus 0, 0. 2 minus 2, 0. So now we're not done here, so we add a 0, and we bring it down. What about 25 into 50? How many times does that go in? Great job. Goes in twice, so 25 times 2 is? Awesome job. 50. 50 minus 50 is 0. Great. So our answer here should be density equals 0.82 grams per milliliters. Don't forget to add in the unit of measurement. So for those of you that don't remember every single piece of the step for division, remember what Mr. Foster always goes over with you. D, you divide first. M, multiply. S, subtract. B, bring down. All right, let's look at question 4. Okay, here it says, students were given 4 unknown substances and asked to observe their characteristics. What's a characteristic again? Great job. Characteristic is like a description. Their observations are shown in the table below. So we have unknown substances here, whether it conducts electricity here, so making it a good conductor or a bad conductor. Its appearance, so the appearance, remember, that's the way it looks, and any other observations that they made after that. So it says, which of the following unknown substances is most likely a metal? So let's think to ourselves. When we're talking about metals, what strategy do we use for metals? Great job. We use Magoo-Doo. So all metals are malleable, meaning it can bend easily. You can hammer it and it won't break. Good conductor, meaning electricity can pass through and heat and stuff like that. Lu, it has a lot of luster. It's very lustrous, so very shiny, meaning it reflects a lot of light. And Du, ductile, meaning you can turn it into a thin wire. What about for nonmetals? What strategy do we use there? Great job. We use BID or BID. B stands for brittle, meaning if you try to hammer it or hit it or something like that, it can break very easily. It shatters easily. I, insulator, so the opposite of a conductor, meaning it insulates, it blocks, or it stops electricity and heat from passing through. And finally, we have D for dull. Dull, the opposite of having high luster, meaning this one doesn't reflect a lot of light, so it's not very shiny at all. So let's look at each individual substance, and at the end, we're going to write down whether it's a metal or it's a non-metal. Maybe it's a metalloid, meaning we use both Magoo-Doo and BID. So let's start with unknown substance number 1. So does it conduct electricity? No. So all of a sudden, since it doesn't, we know that this one is dull. So automatically, we have something from nonmetals. Doesn't mean it's a nonmetal, but we have one so far. Let's go to the next one, appearance. Black and gritty. So if it's gritty, it's kind of like a sand sort of, so gritty. So would that be very shiny? Would it have a lot of luster? No, right? It doesn't. So, oh wait, I'm sorry. I actually totally made a mistake here. I want to apologize for something. I accidentally put dull here, and that was my fault. Not conducting electricity means it's an insulator. That's the I, I'm sorry. Appearance now, since it's not shiny, now this one would be dull. And then observation, snaps easily into small pieces. So that means it breaks very easily. So which one means breaks easily, malleable or brittle? Good job, brittle. So all of these are found BID in nonmetal. So this one right here is a nonmetal. Let's look at unknown substance 2. Does it conduct electricity? Yeah, it does. So that means it's a good conductor. Appearance, it's shiny. So that means it has a lot of luster or very little luster? A lot of luster, very good. And it bends easily. So if I hammer it, I can bend it and reshape it into different things. So where would you find that? Is that in Magoo-Doo or BID? Great job. It's in Magoo-Doo. So in this case, it's malleable. So all of these are found in Magoo-Doo. So this one is a metal. Unknown substance 3. Does it conduct electricity? No. So again, it's an insulator, just like the first one. It's blue. So that doesn't really tell us anything. I mean, if it's blue, I mean, it could be shiny, it might not. I mean, we can't tell, right? We don't know how much light it's going to reflect. So let's just look at the next one. Observation, bends and snaps back to original shape. So if it can bend easily, it won't break easily. That means it's also malleable. So in this case, if it's malleable and it's an insulator, which means you have a little bit of Magoo-Doo and BID, what would you consider this one? Great job. This one would be a metalloid. Finally, unknown substance 4. Does it conduct electricity? Yeah. So, good conductor. Appearance is clear. So if it's clear, there's a good chance that it's going to be, I think it's going to reflect some light there. When you think of an object that's clear, they tend to reflect some light, a really, really good clear, right? So we're going to say that this one right here has some luster, but it shatters easily. So that means it's brittle. So what would this be? Great job. It's also a metalloid because you have different characteristics from both Magoo-Doo and BID. So when the question asks which of the unknown substances is most likely a metal, which one would be your answer? Great job. Letter G, unknown substance number 2. All right, so let's look at this one here. Number 5. It says, compressing a spring increases its blank. So when you compress something, you're squeezing it together. So a spring kind of looks like that coiled thing that you have inside those like pens, where you have the top that you push up and down. So imagine it. We've talked about a rubber band in the past. You know, when you pull a rubber band further and further apart, you're increasing the amount of energy it has to make it go faster and make it go farther. So you're increasing its potential energy, because potential energy is what will determine, you know, what you can do right after that, how much kinetic energy you're actually going to have after that. So in this case, the one that's increasing here is going to be the potential energy. So as you squeeze a spring together, the more you squeeze it together, as soon as you let go, the more force it'll have as it pushes out, because it had more potential to begin with, because you kept squeezing it and squeezing it and squeezing it further. Let's look at number 6.